Chapter 6 is all about time series. So what is a time series? Well, essentially it's just any graph where the explanatory variable, a lovely horizontal one, is time, usually indicated in either hours, days, minutes, months, years, whatever their case might be. We tend to plot a time series much in the same way that you would plot a scatter plot or anything along those lines. A trend. So a trend is seeing whether or not something over a very long period of time is increasing. So whether or not it's increasing or whether or not it is in fact decreasing as we go. We can see here in this graphs here, we can see that on the one on the immediate left there is we generally seeing that as time goes on, there is an increasing trend. We can see in the middle that it's eventually going down. This flat, relatively flat line here would indicate to me no trend. There can also be more than one trend in a single plot, so it can go up and then it can go down. And then what I would just need to say about that is I would actually just need to be specific. So here we can see there is a general increasing trend from 1930 to 2468 till 1956. And then there's a general decreasing trend until 1972. And then there is a further decrease from 1972 to 1996. I would probably describe those as two different levels of types of trends. So for instance, the trend 2 I would describe as how could I describe it? It would be a steeper decrease because it's going down. It's a steeper line. Whereas trend 3, the rate of decrease is much smaller, much lower. Cycles. So cycles are periodic movements in a time series but over a period greater than 1 year. So what does that mean? It just means there's a pattern where things go up and then down and then up and then down. But the pattern of it going up and down is greater than a year. So you can see here that this cycles here are pretty much occurring over decades. So what do you call a cycle where it's going through a year? Well, that's seasonality. So seasonality is suggesting that there is a pattern, a recurring, repeating pattern that's going up and then down and then back up within the year. Now, of course, when we're dealing with data, everything's very approximate, but use your best judgment. A common mistake is people often use cycles and seasonality interchangeably, and you just want to make sure that you don't. You want to say that cycles are the recurring patterns over a year, and seasonality is occurring within the year. If you like to remember seasonality, think seasons. Seasons are within a year. So that would be something to be aware of. Some terminology also you can see here to be aware of. Peaks and troughs. Peaks are these things. So that's the peak up here. That's a trough down here. So it just means the top and the bottom parts. In the regular peaks and troughs in the plot that occur at the same time each year signal the presence of seasonality. So, for instance, you can see here in every June, the June 1998 and June 99, I'm just looking at these ones here, there is a trough, that's where the lowest point is, and similarly June 2000. So that's a clear indicator that we've got some seasonality going on there. Structural change. Structural change is when there's a massive shift. So you can see in these two examples here, it's just a way to describe these things here, that we've got some cycles going on, and then we've got a massive shift, either to decrease or increase there, and that's what we would refer to as a structural change. Outliers is different from a structural change. An outlier would be if you've got a massive difference, but then the pattern resumes back to where it was. So for instance, this is an outlier, that's an outlier, that's probably a bit of an outlier down there as well. The one that's so commonly used to describe these particular graphs is the random fluctuations. Irregular random fluctuations include all the variations in a time series that we cannot reasonably attribute to systematic changes like trend, cycles, seasonality, and structural change or an outlier. So they are always present in any, and there's always present in any real world time series plot. So in other words, a random fluctuation, you might get a strange spike that appears, but generally we can still see a trend. It's different from a structural change. So a structural change means that it's changed the entire graph for differently. So you see in this first example here, the graph was sort of up in this general direction here. Then we got and so I'm looking at this graph here. We can see here we started up here, then a massive structural change, and then the graph continues down there. Whereas these examples here, so for instance, if I look at this outlier graph, we've got a bit of a dip here, but it's not a massive structural change. It's not even that much of an outlier. It's within the realms of the other dots. It's not completely different. So this would be a random fluctuation. The safest bet is pretty much to describe every time series as pretty much having some random fluctuations, unless it's been immaculately drawn as a curve. Example 6a.1. Are the following time series likely to show seasonality? In other words, will there be changes throughout the year? The sale of umbrellas. Well, considering most of the time that the sales would dip in summer, increase in winter, I'd say yes. Sale of shorts? Well, I know that a lot of people like to be very hard and wear shorts all the time and opposed to trousers, but generally people will wear shorts as summer wear during the warmer months, so I'd say yes. Sale of underpants? Well, I don't know I don't know about your particular fashion with underwear, whether or not you feel like in the hot months you're just going to go completely commando, but generally no, it's underpants. We have the sale out all the times. Sale of milk, similarly, we generally like our milk. Apologies to our lactose intolerant viewers here. The occupancy rates at a holiday resort. Well, assuming a holiday resort would be somewhere where you would go on holiday during the holiday times, generally I would say yes. The money earned by teachers. No, that we get a salary every year. Fun fact though, I believe the answer would be yes in other parts of the world. I think that teachers do not get paid on the holiday breaks, but that is a fun fact to research in another time. The money earned by fruit pickers. Well, assuming that fruit pickers are usually hired seasonally, when it's fruit picking season, then we can say yes, well, that is definitely a seasonal thing. 6a.2. The time series plot below shows it's actually to the right there, sorry. Get rid of that, make that to the right. Shows the number of life-saving incidents at a surf beach during a 12-month period. The time series plot has either A, no trend, B, an increasing trend, C, seasonal variation only, D, seasonal variation with an increasing trend, E, random variation with an increasing trend. Well, let's go and have a look. So we're assuming this is months, so let's have a look at our troughs and our peaks. So we definitely can see that it's an increasing trend, so get rid of anything because it's sort of going from lowest. Let's get my little ruler up. If we can see here, it's generally going up. So anything that doesn't say increasing trend, we can get rid of. So it's either got an increasing trend only, it's got season variation only, or it's got random variation only. Well, let's go and have a look. There is definitely a sort of an up-down or an up-down pattern. Is it happening within a year? Well, if this is the months of the year, it's definitely happening within the year. There's just a couple of little cyclic patterns in the year. So yes, it's definitely seasonal. So I'm going to give that a big old D for seasonal variation with an increasing trend. 6A.3. The time series shows the number of passengers a commercial airline has over a number of years. This time series plot indicates that over the 10-year period, revenue from sales each month showed one of those 5 things. Either no overall trend, no correlation, positive skew, an increasing trend only, an increasing trend with seasonal variation. Okay, so we can definitely see it's going up, which is fabulous. So we can get rid of no overall trend. No correlation? Well, there is definitely some sort of relationship we can see here. As soon as we've got a trend, that is another word for saying a correlation, so we can get rid of that. Skew is only really referred to in histograms and histograms and box plots. So since this is neither a histogram or a box plot, let's say new. So we definitely refer to increasing trend only and an increasing trend with seasonal variation. So seasonal variation would imply that it's going within the year, that there's going up and down within a year. So this is in 2-year blocks. So let's go and see here. So about halfway. So remember, it has to go up and down within a year-ish, within 12 months. So if we have a look at this going up, down, up, down, up, down, well, it's certainly within sort of those year frames, it's certainly going up and down. I'm actually going to say that it's an increasing trend with seasonal variation.